Maria manages a bakery, and so what they've given us for this one is the output and the price. And again, these two things here together will equal the demand curve. And then we've got the total cost. So to maximize profits, how many loaves of bread should she sell? Now, to answer these questions, we really need to expand this into the full chart, not just the what they've given us here. So we need to be able to get to marginal revenue and marginal cost in here in order to get the profit. So hold on, let me go to sharing my other screen. So what I have in this one, so we can calculate a bunch of stuff just from having total cost here, okay? So we know that the total cost when we're producing nothing is 3. I mean, the fixed cost when we're producing nothing is 3 because that's my total cost. And so that's going to be 3 the whole way down. So I'll copy that. And we know then that, let's see, let's do this. So this would be total cost at a 0 output. And we know that the variable cost will be the total cost minus the fixed cost. So we can just say that we want to be the total cost minus the fixed cost. And then we can copy that the whole way down. Then we know average total cost is total cost divided by the quantity. So we can take total cost divided by the output, which of course doesn't work when you divide by 0. But if we copy that down, it works for the rest of them. So I'll just forget that one. Oops. Average variable cost will be the variable cost divided by the output. And we'll need some of these to answer some of the questions, not to how to produce. But we've got the same thing here. We'll take the variable cost, which is right here, divided by, the quantity, which is right here. And then we can just copy that all the way down. Okay. Now, marginal cost is the change in the total cost divided by the change in the quantity. And our quantity is going up by 1, so really I'm just looking at the change in the total cost. So I can say this one minus the one before it. So when I went from 0 to 1, my cost went up by 4. And I can copy that guy down. I don't know why that's bigger, but that's okay. And so each one of those is telling me how much my cost went up. So that's marginal cost. Now, marginal revenue, in order to get marginal revenue, I have to get total revenue first, right? Oh, here, let's do these guys. Variable cost divided by quantity. And this is change in total cost. So I'm going to do total revenue first, which is the quantity times the price, okay? So that is this times this. So I'm going to do total revenue first, which is the number of units I sell times the price. Oops, sorry about that. The number of units I sell times the price per unit. If I copy that guy the whole way down, I get this. So if I sell 8 units at $2 each, my total revenue is $16. Now, marginal revenue then is the change in the total revenue. So that's going to be this one minus the one before it. And if I copy that down, each time I sell one, it tells me how much my revenue goes up. And so you can see right here, when I sold the 11th unit, my revenue actually went down by 50 cents. When I sold the next one, it went down even more. And then the profit is total revenue minus total cost. And so I will take total revenue minus, here's my total cost. So if I sell nothing, I lose $3, which is my fixed cost. That makes sense. Sometimes I just like to do a little check to make sure. So if we want to look at profit maximization, we want to look where marginal revenue equals marginal cost, but revenue is still higher. And it looks to me like it's going to equal right here at 5 units, where marginal revenue equals marginal cost. That would mean they should sell 5 units and they would earn $1.50 in profit, which is the best profit that they can earn. And you can see they'd earn the same profit here, but you would always go for the higher quantity if you can. And so that's how we do that one. That's what we did here, and I'll post the answer sheet here. And then the next one just says what happens if the price drops. So what they did was they just changed the prices here, and it changes hers, but we still find here where marginal revenue intersects marginal cost. So all of the cost stuff is the same as the charts that we did in the last one. It's just in this one we have to figure out total revenue first and then use that to calculate marginal revenue. And the other question was this one here with this graph. Eli sells burgers in this market, and how much should he produce? So if we look at this guy, hopefully this is going to work, we find where, let's turn this pen on. We look for marginal cost and marginal revenue, and they intersect right here. So we follow that down, and that tells us the quantity, that he should produce is 1,700, okay? So that's the first thing we find out is the quantity, which is 1,700. Then we follow that up till we reach the demand curve. So here's the demand curve. We follow that over, and he should charge a price of $3.20. So his profit maximizing point is going to be selling 1,700 units at a price of $3.20 each. That's what we're doing. So then the next thing says, what is his total cost and total revenue? So at 1,700, his total cost, we look here for the total cost curve. So we go up, and it looks like his total cost is $2.40. $2.40 a unit. $2.40 is his total cost per unit, and then you would take that times 1,700 units, and then his total revenue, he's selling them for $3.20. So $3.20 is the revenue per unit times 1,700 units. You could also do it this way. You could do, if you just wanted profit per unit, 320 minus 240, revenue cost. So, so here's his total revenue, the price, which is 320 times 1,700, and his total cost we said was 240 times 1,700. So here's his total revenue, total cost. Subtract that. His total profit is $13.60, which we would see as this area right there. The area above the average total cost and below the price he's charging there. And then it asks what happens in the long run. In the long run, it will go back towards that zero economic profit, but the more he can differentiate himself, the longer he can hold on to that economic profit. In perfect competition, it will go back down really quickly, but in here, he can maintain that the longer he can kind of differentiate himself.